Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with Chapter 8, which is about quadrilaterals. And this is kind of a follow-up to parallelograms. It's kind of like the converse of a parallelogram. So we can basically say if something's a parallelogram, then we can say these properties are true. And we're doing the converse kind of, which is saying like if these properties are true, then it's a parallelogram, okay? So we have a warm-up here. It says name 2 of the properties of parallelograms. There's actually 5. If you can name all 5, that would be awesome. Go ahead and pause the video, see how you do. All right, so some properties of parallelograms is that the definition is that opposite sides, okay, are parallel. That's why it's called a parallelogram. We also know that opposite sides are congruent. Oops. Parallel and congruent. Number 3, we know that opposite angles are congruent. Number 4 is that consecutive angles are supplementary. And the last thing we talked about was that diagonals bisect, which means like they split them exactly in two congruent parts, okay? All right, let's go ahead and fill in these boxes here. You can see that a lot of these things we talked about are right kind of there, so very cool. All right, so what we talked about, some theorems here. If one pair of opposite sides of a quadrilateral are parallel and congruent, then it's a parallelogram. So if BD, if it's these are parallel and BC and AD and congruent, then it's a parallelogram. So just one pair of sides. So if you can show that one pair of sides are parallel and congruent, it's a parallelogram. Or if you can say that the diagonals bisect each other, you can also say it's a parallelogram. So yeah, so there's some other ways to prove it besides them just being parallel. Okay, both pairs of opposite sides parallel. Okay. All right, let's move along down here. So, example 1 says, for what value of x is quadrilateral PQRS a parallelogram? So, looks like we're working with the diagonals here. What do we know about the diagonals? Well, the diagonals of parallelograms bisect each other, which means they should be congruent. So we should say that these should be congruent, right? So what are we going to do with them? Well, we're going to set them equal. We got 5x equals 2x plus 9. Okay, so why don't you guys go ahead and pause the video and see if you can solve that. All right, we're going to subtract 2x from both sides. We get 3x equals 9, divided by 3, get x equals what? 3. Nice. Okay, we have a checkpoint if we want to go ahead and just say anything for the checkpoint. Okay, diagonals bisect, these should be congruent, so 4x minus 7 equals 2x. We're going to solve. Oh, and there should be a weird result for this. I should have mentioned that. But if you got something weird, don't panic. It is a weird answer. So we get negative 7 equals negative 2x. Divide by negative 2. Does 7 divided by 2 or not really? It doesn't. So we're going to get x equals, 2 negatives make a positive. We're going to get 7 over 2. And there we go. Cool, cool. Example 2. I don't really like this example that much, but, you know, it's what it is. I want you guys, it says, what theorem can you use to show the quadrilateral is a parallelogram? So don't say what theorem it is, just say, like, what is shown in the diagram that would show that this is a parallelogram. All right, example 1, we got these little arrows here, and we have, these are congruent, so we can say that one pair of opposite sides. So one pair of opposite sides, they're parallel and congruent, and that would show that it's a parallelogram, okay? This one over here looks like these are diagonals, and what do we know about diagonals of parallelograms? They bisect, so we can say this is a parallelogram because the diagonals bisect. And that's all they wanted for that one. Kind of a weird example, but is what it is. Okay, next, using properties of parallelograms. Find the value of x that would make the quadrilateral parallelogram. So it's kind of the same thing. We're still going to be using like properties to solve for x, but we're just kind of like, we're saying like what value of x, basically like we're still solving for x, we're trying to see like what would make it true. Yep, so it's not really very different, but what kind of angles are these? Are these opposite or consecutive? These are consecutive, they're side by side, right? Opposite would be like over here, like these two. So what are we gonna do with consecutive angles? Well, we're gonna set them, not equal, we're actually gonna add them up to 180, they're supplementary. So 10x plus 1 plus 4x plus 11 equals 180. All right, combine like terms, 10x and 4x, 1 and 11, so we get 14x plus 12, 1 plus 11 equals 180. Subtract 12, we get 14x equals, what's that, 168. Divide by 14, and we get x equals 12. Okay, so the value of x being 12 would make those supplementary angles, which would make that a parallelogram. Okay, all right, one last example. Why don't you guys do the same thing for the checkpoint here? Go ahead. All right, what kind of angles are these? These are consecutive angles. Are they congruent or supplementary? They are supplementary, so we're going to add them up to 180. So 21x minus 13 plus 8x plus 19 equals 180. Combine like terms. We get 29x plus 6. These are like terms here too. Equals 180. Subtract 6. 29x equals 174. Divide by 29. Get x equals 6. And there we go. So this is, like I said, just kind of extra practice from 8.2. Just as kind of a twist on it. Okay, that's all I have for you today. Thank you for watching. Have a great day, and we will talk soon.